Hello everyone. We are given a very clumsy looking integral here. The integral is the product of 1 by x plus 1 by x cube times the 23rd root of 3x raised to the power minus 24 plus x raised to the power minus 26 whole dx. And if the result of this product of integral is of the form of minus alpha upon 3 times alpha plus 1 times the product of 3x raised to the power beta plus x raised to the power gamma whole raised to the power alpha plus 1 upon alpha plus c, where x is positive real number and alpha, beta, gamma are all integers, then we are asked to find the value of alpha plus beta plus gamma, right? So this is looking very clumsy, very difficult. Okay, let us start and see if this is solvable in with some easy steps or not. Okay, it looks very difficult, it looks very clumsy, I know. Okay, so let us start first of all. So we are given 1 by x plus 1 upon x cube times the 23rd root of 3x raised to the power minus 24 plus x raised to the power minus 26, right? So what if I try to multiply and divide with a x to each of these terms? That is, I can write this integral as, I'm keeping the first term for the time being as it is, then I'm introducing 1 by x here, right? So if I am introducing one extra 1 by x, I need to multiply with the x, right? So I have multiplied with the x again, and then the last term, that is 23rd root, I've kept it as it is for the time, okay? Plus x raised to the power minus 26 dx, okay? Now what I will do is I will try to multiply this 1 by x with this term and this x. I'll try to take it inside this, okay, inside this 23rd root. Okay, let us see what happens now. So if I multiply 1 by x with each of these terms inside the bracket, the first term will now become 1 upon x square plus 1 upon x to the power 4, right? And if I try to bring this x here, what you need to understand is basically if I write something as x root 7, if I take this x inside this root, since this is a square root, this will become 7x square inside the root, right? Similarly, if I write cube root of say 7 times x, then when I take this x inside this cube root, this will become 7x cube, right? So here this is 23rd root, right? So 23rd root of whatever, say k, and the x is outside, so this will become k x raised to the power 23, right? This is 23rd root, right? So if this x goes inside, all of these terms will be multiplied with x raised to the power 23, right? You have understood this here? Okay, so this is what I am doing. So inside the 23rd root, basically I'll multiply x to the power 23 with each of these terms, right? So this is 3x to the power minus 24 plus x raised to the power minus 26 dx, right? So I'm keeping this first part for the time being as it is. So this is 1 upon x square plus 1 upon x to the power 4, and then we have 23rd root of, on multiplying these two, this is x to the power 23 and this is x to the power minus 24, right? So this will become 3x to the power minus 1, which is nothing but 3 upon x. Similarly, this will be x to the power 23 times x to the power minus 26. So this is x to the power minus 3, right? So this just becomes 1 upon x cube dx. So you see it now looks much more simpler than it was originally, right? Originally it was looking very, very difficult, very clumsy. Now at least the structure is a little bit better looking. Okay, so if I take this thing inside this 23rd root as u, chances are that basically if I take either this as u, this first term, it can be expressed in this form, or if I take this as some u, can I express it in this form? Okay, let us see. So if I take this, let u to be this 3 upon x plus 1 upon x cube, I'm taking this first because if you look, this is x to the power minus 3, right? And this is x to the power minus 1. So if I do the ddx, chances are it will become x to the power minus 2, which is present here. And x to the power 3, if I do the derivative, chances are x to the power minus 4, which is present here, right? So let us see if anything happens or not. So this will give us du equal to, this is 3x to the power minus 1, right? So this will become minus 3 upon x squared. Similarly, this is x to the power minus 3. So this will become minus 3 upon x to the power 4 whole thing dx, right? So if I take a minus 3 common here and take it to this side, this will become minus du upon 3, and this will give me 1 upon x square plus 1 upon x to the power 4 times dx, right? So you see I've already got this part, right? This term and this dx term while taking this as u. Okay, so this has now changed to, this is just u raised to the power 1 upon 23 times minus 1 by 3 du, right? You can look carefully again in the right hand side. I have done the derivative here. You see carefully. You can pause the video and look carefully. I think it is all right, right? So this has now become very easy now. Okay, so I'm taking the constant out, and this is just x to the power n dx, right? So this will just become u raised to the power 1 by 23 plus 1 divided by 1 by 23 plus 1, right? Plus c. So this just becomes 1 by 3 times. This will become 1 plus 23. So u to the power 24 by 23, I believe, right? And similarly here also it will become 24 by 23 in the denominator plus c. Okay, so if I change it, this will become minus 1/3 times 23 upon 24 times u raised to the power 24 upon 23 plus c. Okay, so now let us do the original back substitution again. Okay, so if I do the back substitution again, this has to come in this form, minus alpha upon 3 times. So if I do this substitution again, back substitution again, this now becomes minus 1/3 times 23 upon 24 times, this is u is nothing but 3 upon x. 3 upon x can be written as 3 x to the power minus 1 plus, this is x to the power minus 3, right? 1 upon x cube whole raised to the power 24 by 23. So the format was minus alpha by 3 times alpha plus 1, right? So if I write it like that, 3 times alpha plus 1, so this is 24, so I have to write it as 23 plus 1, right? And this is again product of minus 1 and 23 is again minus 23, so this is done, right? Alpha minus alpha by 3 times alpha plus 1, so alpha is 23 from this expression, right? Now let us look at the other part. Other part is 3x to the power beta. So 3x to the power beta is again here done. 3x to the power minus 1 plus, it was x to the power gamma, right? So again this is x to the power gamma. So I think we have found alpha beta gamma already, and the power was 20 alpha plus 1 upon alpha, right? So 24 by 23 can be written as 23 plus 1 by 23, right? Okay, so this is already in the form of the required given expression, right? Minus alpha by 3 times alpha plus 1 multiplied with the product of 3x to the power beta plus x to the power gamma whole raised to the power alpha plus 1 upon alpha, right? So this is equivalent to this minus alpha by 3 times alpha plus 1 times 3x to the power minus beta, not minus beta, I believe it was just beta. So it's 3x to the power beta plus x to the power gamma whole raised to the power alpha plus 1 upon alpha plus c, right? So if we compare these two, clearly we have alpha equal to 23, beta equal to -1, and gamma equal to -3, right? So the value of alpha plus beta plus gamma is just 23 minus 1 minus 3. So this is 23 minus 1 minus 3. So this is 23 minus 4. So this is 19. Okay. So I believe this is the required final answer. Okay. So the integral was very tricky. You know, it was very tricky while solving it at home. I needed some time, but once you do it, you will feel a satisfaction, right? It is very tricky. I know in the exam hall, if you have not done such integrals before, and if you see it for the first time, this can be a bit difficult. Okay, so you try and solve such integrals for the upcoming seasons if you are appearing again, or if you are appearing for the first time. Okay, but this was slightly tricky. It was very tricky, but it was very satisfactory. Once I was able to solve it, it was very satisfactory. Okay, it's not that difficult. Once you do the substitution, it becomes very solvable, right? So this is the required answer, 19 here. Okay, so if there are any doubts in any of my steps, you believe there are any doubts, you can highlight in the comments. Okay, so this is the required answer. Thank you for watching.